we are good to go. Right, first thing I want to do is a tidy up thing. I guess I'll call it a tidy up because I can't think of what else to call it. From our previous section, the one that we were still on at the end of yesterday. So it was what, 2-2. And we're going to look at how do you use a table of values to do that. Now, I could simply just put that function into WebAssign, and you're pretty comfortable from 141 that there is a vertical asymptote at 2, right? And so I could do it that way. Depends on what type of vertical asymptote you get at x equals 2. Could this be positive infinity? This might be negative infinity, and therefore this does not exist. But let's suppose we want to do it as a table of values instead. Now, if you want to get only that limit, then you have to be a little bit more selective about who you put in your table, because that limit is the limit as x approaches 2 from the left-hand side, right? The 1.99 side. So you would set up a table something like this. And you would choose consecutive values that are getting closer and closer to 2, but from the small side. So how about some like maybe 1.9, 1.99, and then finally 1.999. Do you see that there's only those numbers, right? I don't have the ones the other side of 2, for instance, right? So once you've got that, got my calculator handy. All right. This is the, setting up part. So I go y equals, I do an x divided by, always remember the brackets to get ordinary calculation right. So there's x over x minus 2. My table has been set up. So if you've set it up, you leave it alone. And then you go to here. Just realized that was just the right numbers, but never mind. 1.9, 1.99. And finally 1.999. Now, if you look at the values that we're getting here, the value of the function when x is 1.9 is negative 19. And then as you get a little bit nearer, it's negative 199. And as you get even nearer to 2, you end up with what? Negative 1000. And then you look for essentially a trend. And the trend here, would you agree, is that it's getting extremely large and negative, right? The next one would be, maybe negative 19,000 and negative 19 million and so on, right? As you get closer and closer to 2, won't this answer just get bigger and bigger and bigger as far as negatives go? So we would be able to then say that. Okay. Now, suppose you want to do this one. You're going to set up a table, because that's the way that we're tackling this question. And we have to look at what consecutive values are going to look like. Well, in 2 plus, that means you're coming in from the right-hand side. So it's going to be, like the 2.001 side. And so I'm going to go 2.1, 2.01, 2.001. Right. If I go to my table of values, I guess I could just delete these so that they're not a distraction. I get 2.1, 2.01, and 2.001. And what's the answers look like? 21. Then it becomes 201. And then it climbs up to 2001. So as we get closer to 2, would you agree in this case? Plus infinity. So this limit, plus infinity. Technically, you don't need to put the plus around it, because if you don't have a symbol, it means it's positive. So this one here, I don't need to do a table of value. If this guy is negative infinity and this guy is positive infinity, what can I say about the overall limit?
dnu.
dnu does not exist. And if you wanted to imagine what that might look like, there's a vertical asymptote at x equals 2. And as you come in from the left-hand side, it's negative, which means it's coming like that, right? And if you come in from the right-hand side, it looks like that. And I bet you if you put that guy into Desmos, you would see a vertical asymptote, just the same shape as I have here. Are we comfortable with that? A different way of deciding or finding left, right, and overall limits when the answer could be infinite. So we are now moving on to our final section for today, what we need for our test, our online test, and for our homework. And that is section 2.3, where we're going to be looking at how do you, is it 2.3? 2.2? What number is it? It's 2.3, okay. How to find the limit of a function, essentially using algebra. And we're not going to get an estimate for the answer. Do you know when you do it numerically, it's 4.999 and you say, well, it's probably going to be 5, right? That's the kind of estimate method. We're going to show you how to get exact values for limits using 3 techniques. The first one is called the evaluation method. The second is called factor and cancel method. And the third one has a really strange name, but it's called the conjugate method. So let's show you what the evaluation method looks like. If you want to find, let's say the limit as x tends to 3 of x squared plus 1 over x plus 2. The evaluation method is very simple and isn't used much because it really isn't much of a problem to solve. You simply just plug in 3. And that gets you 10, and that gets you 5. So the limit would be 2. Would you agree it's a very simple way of solving a problem? You want to know the value of the limit of a function at 3? Find its value at 3. If it's a number, that's what the limit is going to be. And the rules of limits, right? The laws of limits say that if that happens, you've got your limit, right? Evaluate. Can you expect that that's not going to be your major go-to method, but it works. Now, the evaluation method doesn't work all the time. If I try to evaluate this expression at 3, I would get 3 squared take away 9 over 3 take away 3, and that gets us a very nasty surprise. We get 0 over 0. Now, in mathematics, 0 over 0 is bad news, right? We don't know what that answer is, right? Now, you might say, well, it's 1, right? 0 over 0, something over itself should be 1. No, it's not 1. Might be, but it just might not be. It could be infinity, could be 0, could be 42. We call that situation where you get 0 over 0, even has a name. It's called an indeterminate form. The word indeterminate just means we don't know. I don't know what 0 over 0 is going to be in this particular situation. And it's because the evaluation method doesn't work all the time that we need the other two, right? See, if you could just plug the number in and get an answer, wouldn't that be what we do every single time? But we can't. So we have to figure out a new, different way of solving questions where you've got an indeterminate form. So normally what you should do when you've got questions about finding limit is you should try this method first, because if it works, you've got the answer and you're done. You try it and you'll get indeterminate form, then you know to use one of these 2 methods. And we'll tell you how you can tell which one is a more appropriate method to use. Just pretend for a minute I did another calculation. what would the answer be if it was 0/3? Imagine that's what I got. What would that be equal to?
0.
0. So would you agree that's not a problem? Doesn't the evaluation method work totally fine? The limit is 0. Nothing wrong with that. Three over 0. What would that get you?
Does not exist.
We do say does not exist, but we've kind of refined the does not exist now that we're into limits. So I'll tell you what your choices are. 0, a number, or some kind of infinity. So from only those three choices, what would that get you? Yeah, some kind of infinity. Would you agree if you take a number and divide it by 0, the answer is going to be infinitely large? Right? Probably in this case plus infinity. So those two are not indeterminate form. It's when both of them are 0 that you have the problem, right? So if that happens, the answer is 0. If that happens, the answer is infinity. And if that happens, you say, okay, let's try another technique. So let's show you the technique called factor and cancel. I like the name of this. Yeah, I sometimes make up names for things if I don't like the name they've got. I have a name for as long as you do it to both sides, it's okay rule, which is my name for, you know, the method that you use to solve equations, right? You add 2 to both sides and so on. This is called factor and cancel. I like it a lot. So let's return back to this question and we'll show you how the method works. The name kind of tells you what to do. You factor. Okay, that means you're going to have to brush off the cobwebs and remember how you factor quadratics, because most of them will be quadratics. What is x squared minus 9 when you factor it?
X plus 3, x minus 3.
You recognize it as a difference of 2 squares. Right. Now, that's the factor part. Now there's a cancel part. You can cancel this guy with that guy, right? A 1-for-1 deal. So what you are left with is a much simpler limit that has the same answer or the same value as the original. Isn't that all you're left with? I guess x plus 3 over 1, but that's still x plus 3. And here, you can now replace and you get your answer 6. So I can tell you the exact value of that limit is 6. It's not based on my table, it looks like it's probably going to be 6, or looking at a graph as far as I can see, the whole is at 6, right? It is exactly 6, right? The algebra, the math has given us there's no gray area, right? It has given us a precise value. That's pretty cool, isn't it? That we now have a technique for doing that. So I'm going to choose some more factor and cancels because we can. This one is aversion equation 5. We're going to do the limit as x tends to -3, and the top is x squared plus 3x, and the bottom is x squared take away 4x, take away 21. So we'll begin with the factor. Quadratic, different situations. This one here, factors like that. Let's focus on the top. What would be the factor that you would use on the top? X squared plus 3x.
Factor out x, so it's x plus 3.
Agreed. Now, the bottom's a classic trinomial, right, a quadratic. And since this is x squared, you have an x and an x. Since this is negative 21, you know you're going to have a positive and a negative. So you look at all the combinations that give you negative 21, right? Two numbers that multiply together, that give you negative 21. But when you add them together, combine them, you get negative 4. And there should only be one.
3.
Say again?
-7 and +3.
Agreed. Now, there is a little clue in this question. One of these guys in the bottom be one of these guys on the top, right? That's how the method's going to work. So I would be saying, hey, there's an x plus 3 here. So I know one of them's pretty much guaranteed to be x plus 3. And that makes it a little bit easier. Can you imagine that number, some ridiculous like 125 or something, where there's so many combinations you could be looking at it for a while? Well, if you know one of those plus 3, can't you figure out the other one? Right, it's going to have to be that. Well, now we can cancel. 1 for 1. And we get the limit as x tends to -3 of just x over x take away 7. And at this point, you can simply just plug in -3. And what's that? -3 over -10, which gives you positive 3/10. Cool. We have a way of finding exact values for limits by using this method called factor and cancel. Here's another one. The limit as x tends to -3 again of x squared, take away x, take away 12, and a 4x squared add an 11x, take away 3. Right, two trinomials, right, two quadratics. Who feels lucky? Pick top or bottom and tell me what the factors are.
So for the numerator, the factors are going to be x minus 4 and x plus 3.
Correct.
And for the bottom, we're going to have a negative correction. We're going to have a positive 3, a negative 1, and 4 in front of the first x.
Yeah. Now, when you are doing this factor and cancel method, especially when the quadratics, maybe like this one, starts getting ugly, there are certain features you might have noticed that every single question has. Do you see how the value here is the limit as x tends to -3? Do you notice that that causes an x plus 3 as a factor? If this was the limit as x tends to 7, I bet you would have an x minus 7 and an x minus 7. So you can actually use this number to indirectly figure out the common factor, because the top one is going to have the same as the bottom, right? So if this is an x plus 3, the way this is going to work, won't that also have to have a common factor? It's going to have an x plus 3. Now, we can cancel 1 for 1. And now we are looking at the limit as x tends to -3 of x minus 4 over 4x take away 1. And I'll put in, replace the x with -3. And that's -7 and that's -13. So you get positive 7/13. Looking good? Any questions so far? Evaluate method, you just plug in the number. I've not done it lately, but see if I plug -3 into here, the answer would be 0. If I plug -3 in here for x, it would be 0, right? I'd get that 0/0 indeterminate form. I would guarantee that. So how about this question? It still qualifies as a factor and cancel, but it's not a pretty one, and it's not as straightforward as you'd expect in most cases. It's all about algebra, right? Algebra is your friend. Algebra and math is how you get answers to things, right? It helps you get there. What on earth could I do to the numerator?
Expand it.
That would be it. FOIL it out, right? Expand it. You just trust me on this, that the answer ends up being that. Take away 16. Do you know, a lot of people, I'm not quite sure why, a lot of people think that h minus 4 squared is just the h squared plus 16 bit, right? They forget the -8. If you're one of those people, it's probably a good idea to go h take away 4 times h take away 4 and FOIL it out, because that's what you get. And again, I'm still not going to do the factor and cancel quite yet, because don't these cancel out? Yeah. Now, isn't this one ready to go? Let's factor it and cancel that. The numerator, this guy, has a common factor of h, so I'll pull that out. That's the factoring done. A 1-for-1 cancel. So we are now going to be doing the limit as h tends to 0 of just that guy. Plug in 0 for h, and bingo. Cool. There's one more method that we haven't tackled yet, called the conjugate method. So let me tell you when you should use the factor and cancel, and when you should use the conjugate. When your expressions have square roots in them, none of the ones we've done have them yet, but when your expression has a square root in it, use the conjugate method. If it doesn't have a square root in it, factor and cancel. So that's the way you tell. If your fraction has a square root.
Sorry. How
Say
come
again?
the 8h is positive?
How come the
8h. Why did it become positive?
oh goodness gracious.
Oh, okay. I thought I was losing my mind.
No, you're not. There we go.
All right.
Yeah. All right, that gives me a chance. We'll come and look at that right now, but that's a good example. You may think that because I've been teaching for 42 years and I've got a couple of degrees and I've done math a long time, that if I write down 2 times 3 and I say it's 5, that it's just some weird algebra you've never seen before and I must be right. No, it just means I made a mistake. And I like it when people tell me, hey, how come that became a plus and I thought it should be a minus? Because the chances are I made a mistake and you're the only one who at least had the courage to say, I think you might have done something that I'm not sure about. Is that a mistake? And I strongly encourage you to always do that. If you think I've done something that's not right, or I've wrote down something that's not, you know, a plus that turned into a minus, you tell me. And 9 times out of 10, you will be right. And 1 out of the 10 times, I actually didn't do anything wrong, and you just maybe misinterpreted it. I don't care about that 1 out of 10. I'd rather get you catch all my mistakes, and a couple of times it wasn't a mistake. I'll be much happier. So that's your job in life, right? To keep an eye on me in case I screw up. So let's return to this conjugate method. You're only going to do it in a very limited situation when there's a square root. So let's jump right in and show you one. I want to find the limit as x tends to 16 of 16 take away x over 4 take away the square root of x. Now, do you see what I'm talking about? There's a square root in the answer, right? Pretty clear. Now, it can be the square root of x. It can be the square root of x plus 7, right? So there's an x plus 7 inside it. Any kind of square that looks like that, you are going to say conjugate method. So let me show you how this works. We are going to do a cool trick in math, which is if you can't solve the problem the way it's written, change it into a different problem that you can solve. Solve that one and use its answer to answer the original, right? So instead of trying to smash through the brick wall, we walk round the back of it, right? We find a way around the issue. So in these fellas, the guy that's causing the trouble, which is 4 take away square root of x, I'm going to take this fraction and change it by multiplying it by a special version of 1. Now, a 1 is just the same guy in the top and the bottom. So if I multiplied it by 5/5, wouldn't that be the same as multiplying it by 1, right? Now, if you multiply something by 1, you do not change its value, right? It's still worth what it was worth. Don't you just maybe change the way it looks, right? So what special version of 1 we use has a name. It's called the conjugate. That's probably why this is called the conjugate method. And it's the square root guy, but with the opposite sign, typically plus. So you multiply by the special version of 1, the conjugate version, 4 plus the square root, right? Now see if this was 4 take away the square root of x plus 6. This would be 4 plus the square root of x plus 6, right? That's how you would do it. Now, once you've multiplied by the special version of 1, the next step is that you FOIL them out. Now, if you take this top guy, I'm going to FOIL it, and we take this bottom guy, I'm going to FOIL it. I'm going to do it in a separate piece of paper because it takes up a lot of room. So here is 16 take away x, the numerator, multiplied by 4 plus the square root of x. And forget that. Do not do anything to it. But multiply the guy that was causing you trouble. In this case, the guy that discovered it. You'll need to do that. If I'd done that top multiplication, do you know I wouldn't have done anything any good? Because my next line would be to factor it back again, right? Because I don't want to keep it separated. So FOIL. 4 times 4 is 16. 4 times that guy gets you this. Negative root x times that gets me that. And negative the square root of x multiplied by positive the square root of x, doesn't that just get you negative x? Square root times the square root. Now the 2 in the middle kill each other off, and you're left with that. And maybe you'll see why it was a good idea for me not to bother to FOIL the top out, because isn't it actually kind of nice? Do you see something cool that's going to happen? What can I do next then?
Cancel 60 minus x.
And what we're left with looks like that. And now I could plug in x, that's 4, and 4 add 4 is 8. So when you're doing the conjugate method, multiply by special version of 1. Leave these guys alone. Only FOIL these out. If things work out, somebody in the top will cancel out with somebody in the bottom. You'll be left with a much simpler expression, which you can then evaluate. That's essentially how it works.
Professor?
Yes.
Question regarding the square root. I often see it as plus or minus. In this instance, we only deal with the positive.
When you see the plus or minus square root, it's happening because something like this. And you're taking the square root of both sides. And because of that, you do a plus or minus.
Okay.
Now, when we
Solving
write
for
something like 4 plus square root of x or 4 take away square root of x, those, you only get one, right? And it depends on what you're told. So in this original question, that is 4 take away square root of x. It's not a plus or minus. It is whatever they say it is.
Not solving for the missing value they've
No,
already given us.
we're not trying to solve for it.
Thank you.
Okay, so let's try another one of these guys. This is a version of question 10. A little bit messier. It's going to be the limit as h tends to 0 of the square root of 36 plus h take away 6 all over h. Now I can definitely, can you trust me that if I plug 0 in here, I'd get 0 over 0, right? So the indeterminate form. So I'm now going to multiply by the special version of 1. You look at the guy that's got the square root and you write the same two guys, but with a plus. Are you comfortable about that line? Multiply by a special version of 1. I won't do anything to the two terms on the bottom. There is no advantage to me to multiply them together. Leave them alone. But what I will do is the two square root guys. Now, if you multiply this guy by this guy, we use FOIL. So there is the first one. Oh, squeeze it in. There is the second one. The f of FOIL is the square root of 36 plus h times the square root of 36 plus h. If you multiply a square root of something by the square root of the same thing, don't you basically just get what's inside, right? It's like square root of x times square root of x. So that's the f part. Now, if we do the O of FOIL, we have a square root, just this piece, times 6. So you're going to get 6 square roots. And that's the O. Now, if you do the inside, it's a negative 6 times that guy. So you get negative 6 square root of 36 plus h. That's the I part. And if you do that times that, you will get negative 36. And that's the L. Have you noticed, I know it's only like 2 situations, but have you noticed that all the square root stuff kind of kills each other off? And all you're left with here is a 36 plus h, take away a 36. And now I've thought about that,
Uh-oh.
don't we just get h? Agreed? And so that is h. There's a surprise. Now, 1 for 1 cancel. Remember to leave a 1 behind if it's a situation like this. So it's going to be the limit as h tends to 0 of 1 over the square root of 36 plus h plus 6. I can now replace the h with 0. So that's going to be square root of 36 plus a 6. And that ends up being 1/12. So the conjugate method should be used when you're trying to find a limit and there is a square root somewhere. And if you want to save some time, you can very often get used to this top, the FOIL thing, and you can predict what the answer is going to be without actually doing the entire FOIL. Once you get fast at it, you can do that. But if you feel a little bit uncomfortable, just do FOIL every time, then you'll get the right answer. Everything cool so far? Any questions? Right, let's make life just a tiny bit
Yeah,
tricky.
I've got a question.
Good, what you got?
So I noticed when I was doing these that the answer is always a positive root, never a negative root. So
Yes.
36 square root of is 6, but
Yes.
isn't square root of 36 also -6?
All right. Robert was saying a similar thing. When you write down, let's say square root of 9, the fact that you've written down that means that you are only picking the positive. And so the answer will be +3. If they wanted it to be a negative, the negative would have to be in the question. And so I think what we're picking up is that habit that we've told you when you solve equations and you take the square root of both sides, there's a plus and a minus choice. But we are not solving equations here. We are just evaluating a square root. And the rule for square roots is that guy is 5 and that guy is -4. You see the plus on the minus is included inside the question, right? What they tell you is what it is. That makes sense?
Yeah, it does.
Okay. So, oh yeah, this one. Well, I have a couple like this, but this one I think I'll start off with. The limit as x tends to 2 of 2 take away x, nothing too weird happening here, square root of x add 2, take away 2. Okay, let's throw it on to you lot. What is my conjugate going to be? What will I write here and here?
Square root of x plus 2 plus 2.
Are you all comfortable how you come up with that guy? Isn't it the same as this guy, but with a plus? That's pretty much it. There's no subtlety there, right? Whatever the square root thing is, same square root thing, but with a plus. Now I'm going to cut some corners here for time. I'm not going to do anything to the top, but I am going to multiply these two guys together. And I'm going to tell you that that guy times that guy gets you x add 2. And that guy times that guy gets you take away 4. Are you comfortable that if you foiled that out, this is what it would look like? First guy squared, take away second guy squared. And the reason for that is that this is actually a difference of 2 squares. Square root guy squared, take away 2 squared. Now that's the shortcut. If you don't like that, just FOIL it out the way I've done the other 2 questions. Now that simplifies a little bit. And the reason I chose this question was because this situation in front of us. We should be able to cancel. You told me this is what happens, right? Some cancels and then we can get the answer. And then you're looking and you're saying, but this guy isn't that guy, right? They look different. So where's the cancelling that you promised me? Well, it's there.
So I ran into this before
Mhm.
when I was doing one of the homework problems. And what I did was I multiplied the fraction by a -1/1. So that changes the sign of the
It does.
denominator.
You
But I
don't
had-
want to do that, Keith, because what will happen if you did what I think you said is that you will get the right number, but the sign will be wrong. In other words, you'll get 5 and the correct answer is -5, or you'll get -10 and the correct answer was +10. And the reason for that is that if you multiply the top by a different than the bottom, right?
well,
You're
because
changing the value.
because you have two terms in the numerator,
Mhm.
the negative sign only needs to go in front of one of them.
Right.
You make the whole thing, negative if you were, going to.
Right, but so you were saying, if I heard you correctly, you were making this negative and leaving this as 1, correct?
No.
Okay.
I was making the bottom one change of sign. It becomes 2 minus x, and then the negative sign goes in front of the second term of the numerator.
That is totally okay. That works.
Yeah, that's what I ended up doing, and it worked out for me.
Right. So let me show you just a different approach to exactly what you were doing. These two things are allowed to cancel. If I went and said to you 7 minus x over x minus 7, it might be in a while since you've done that. You are allowed to cancel this, but what's left behind? Negative.
Yeah, you're
1.
gonna have -1.
Right. So what that means is that if you ever have a cancel like this, where it's not the same exactly, but they're like reverses of each other, you are allowed to cancel, but just remember that you leave behind a negative. And so what we now have is the limit as x tends to 2 of negative that guy. And now I'll plug in my x value. So it's going to be negative the square root of 2 add 2, negative square root of 4, which is 2 add 2, -4. And so the answer would be -4. Does that make sense? You are allowed to cancel a minus b and b minus a. But when you cancel that, your answer has to be negative, right? And that's how you cope with that particular situation. Right, let's look at another situation. What am I doing here? Let's do this one. The limit is t tends to 0 of that ugly looking thing over t. Right, so we need to multiply by the conjugate, right? That's how you do this method. And so our conjugate is going to come from the square root things, right? These guys. So what would my conjugate be this time?
Plus at the back plus square root 3 minus t.
Yeah. Are we good with that? Same two guys, but a plus. Now, won't do anything to the two terms on the bottom. But I will FOIL these out. And the shortcut, if you want to do it, is the first guy squared, take away the second guy squared. or FOIL it out the long way, but that's what you'd get. Now I'm going to collect like terms. Essentially 3 take away 3 goes away, t take away a t is add a t, so you get 2t. And it looks much nicer. And I get a nice cancel, a 1 for 1. And we can now do the limit as t tends to 0 of what's left. And we plug in 0. Square root of 3 plus nothing is just the square root of 3. Square root of 3 take away nothing is still the square root of 3. And we're looking at that answer. And now we come to a thing, if you've had me before, you'll know what I'm talking about. We come to a thing that I call style points. Style points is really making the answer look as simple and nice as possible. And we can do quite a lot to this answer to make it look prettier, right? Simpler. Anything I can do that you can see?
Combine the square root of 3, so it's 2 over 2 square root of 3 and cancel the 2.
That is not the square root of 6. Hopefully nobody thought that, right? The square root of 3 add a square root of 3 just means you've got 2 of them, right? You've got 2 square roots of 3. Would you agree that we can cancel this?
So what you can do is you can cancel the 2s, but then also if you want to get the square root of 3 out of the denominator, you can multiply by a square root of 3 over square root of 3, and that'll give you square root of 3 over 3.
Yeah. And that process of taking a fraction like 1 over square root of 3 and getting rid of the square root in the bottom, it's got a fancy name. It's called rationalizing the denominator, that you might have seen, I hope you have. And that is considered, you know, the prettiest form of the answer, right? It's much prettier than that, would you agree? It's tidier.
Now, is there a requirement to rationalize denominators, or is that a choice matter?
Oh, you're not going to like this answer. WebAssign is very generous. In other words, it will take things like 1 over root 3. I am not so generous. So in tests and things, I expect you to rationalize the denominator. I expect to see this answer. It's good math to always simplify your answer to its best and simplest form. It's just considered good math. It's a bit like nobody ever tells you 2 quarters should be called a half. Do we all agree that if that happens, you just do it because it's what you should do? 1 over root 7 should be converted, right? Now, does that mean it'll be a problem in your homework? No. If you type in 1 over root 7, WebAssign's very generous. It'll probably say you're correct and move on. And so it won't affect your homework grade unless WebAssign decides occasionally to be, you know, pernickety. But in the test, I will expect you to do that. By that, I mean in the midterm and in the final. Everything else, you can be a little bit more lax. Right, time to pause. Are we good so far? Are we comfortable with the conjugate method? You've seen a few of them. You're getting kind of into the swing of things. Right. So let's move to questions that don't fit into any of those categories, at least directly. Because there are lots of possible fractions in the world that you could be asked to find the limit of, right? And so sometimes you can't work with a standard method. They'll work 90% of the time. You're going to get stuck with questions like this. And when you get stuck with, or whether, whatever the phrase I want to use here is, when you get challenged by a weird looking fraction, that's definitely not a conjugate method. would you agree that there's not a square root anywhere? So that it's a non-starter. If you plug in 4 for x, can you trust me you get 0 over 0? So evaluate method is gone. Now, if you look at that guy, would you agree that there's nothing factorable, at least nothing obvious? So you're going to go and say, oh, that's it. I've ran out of methods. I'm going to go home now and take my ball because I don't want to play anymore. Or you can say, let's figure out just a way of getting around this problem. And this is how I'm going to get around this problem. I am going to multiply by a special version of 1. And the reason I'm going to do a special version of 1 is that my problem really is caused by that ugly numerator. Would you agree that 1 over x minus 1 over 4 is stopping me getting anywhere useful, right? Now, the special version of 1 that I'm going to use is going to make that 1 over x stop being a fraction, and it's going to make that 1 over 4 stop being a fraction. Right, if I multiply the top and bottom by 4, won't the 1/4 just become 1? So it's gone. If I multiply by 4x, however, won't I get rid of both? Do you see why I chose 4x here and not 4 on its own or x on its own, right? So move on to phase 2. Leave the bottom 2 alone. Just kind of rewrite their order. And go 4x times 1 over x, which is 4. And 4x times -1/4, which is -x. Are you happy about that? And this is the second time this has happened. But when you see something a second time, it's a little bit easier to deal with, right? Because you remember what you did the first time it happened. Can I cancel anybody?
Yeah, you can cancel the 2 terms in parentheses, and you're now going to have -1 in the numerator.
Yep, agreed. The answer is going to be negative. So it's going to be the limit as x tends to 4 of essentially -1 over 4x, which is -1 over 4 times 4, which is -1/16. So that didn't fall into any of these categories directly, but with a little bit of algebra, didn't we get it into a form that we could deal with, right? And that's the goal. Make it look like something we can deal with. So our next guy. How about this one? Well, this one's got a couple of things that are not normal. For starters, aren't there 2 variables, h and x? We've never dealt with that. We've always had just one variable, x or h, but we've never done a question with both. And there's no square root in it. So I can't use the conjugate method. And if I plug h equals 0 into here, this becomes x cubed, take away x cubed, which is 0. And this also becomes 0. So I've got indeterminate form. So I can't evaluate it. So I have to figure out, what to do. So unless you've done the homework early, this is the first time you've seen this question. Where should we go? What should we do?
Expand the top.
Okay, now x plus h cubed will take you quite a long time to do, because you basically have to do x plus h times x plus h, get that answer, and then multiply it by 1 more x plus h. So you're just going to trust me on this. Can you trust me that that's what you get when you're finished? And of course, take away x squared. What do we do next?
We can factor out the h from the numerator and then cancel.
We are definitely going to do that. Is there something I should maybe do before that?
The x cubes zero out.
Now let's do what you said. Let's pull out h as a common factor from the numerator. Okay. Every step is getting closer to the answer, right? Every step is helping us on that road. What do we do now?
Well, once you cancel the h's, then you can substitute the remaining h's for 0, and you end up with an answer. You know, the limit is 3x squared.
Sounds good. So you cancel out the h's. You then make h 0. And what do you get? Well, you get 3x squared. 3 times x times 0 is 0. And 0 squared is 0. So the answer is 3x squared. Cool. So we have looked at a number of different limit questions, but every single one that we've dealt with today, so far at least, has been using one of these 3 methods, or we've adapted the algebra so that eventually the factor and cancel method gets used, right? So what is left? Well, there is one question that I haven't done yet, that we're about to do presently. And it's actually question 1 from the homework. And I deliberately left it out because it's a distraction. The vast majority of questions that you're going to do are, you know, these guys, right? Evaluate, factor and cancel, conjugate, or do a bit of algebra, right, and get the answer. This one says that the limit as x tends to 2 of a function is 9. The limit as x tends to 2 of a different function, g, is -4. And the limit as x tends to 2 of a third function, h of x, is 0. So we are told what the values of these 3 limits are. And allegedly, and the answer is yes, you can, we should be able to find the value of these guys. Okay, so what would the limit of f of x plus 2g of x's be? So imagine you just combined the functions and then you evaluated their limit. Well, I know that this guy is 9. And I'd add 2 of these guys. And that would get me 9 minus 8. That would get me 1. Does that make sense? That you can actually, if you tell me what the limit of a function is, say at x equals 2 or whatever it might be, I can then tell you the limit of versions of that function. So that answer would be 1. That's all you would write down. And let's do a little submit answer. Okay, works good. What about this fella? What would the limit as x tends to 2 of the square root of f of x be? It's a number. What would it be?
3.
I didn't. Someone said something, but it's so quiet I didn't pick it up.
3.
3, yes. Isn't it just the square root of whatever the limit is, and the square root of 9 is 3? And it's not plus or minus 3 because if they wanted it to be negative, wouldn't they put a negative at the front? If they wanted it to be positive as they do here, they wouldn't. Now, you could get something messy like that, but wouldn't that be 4 of these guys divided by that guy? And I believe the answer would be -9. Yeah. This one is the weird one. G of x over h of x. G of x is -4 and h of x is 0. So that guy would be -4 on the top divided by 0. And we don't have in this particular situation much in the way of choices. So in this situation, they are going to say DNA. You know, sometimes the answer is plus infinity. Sometimes the answer is negative infinity. Sometimes the answer is does not exist, right? Unless I had more information, the best I can say here is does not exist. I think it would be better to call that undefined because we're not sure what the answer is. Because, I mean, it could be infinity, couldn't it? It could be negative infinity. It could be, you know, there's no overall limit. Are we comfortable with that guy? Right, so I'm now hopefully going to update this cell. Good. So let's go on student view. Have you noticed that the online test one is now available? And you see that funny little symbol that looks like a stopwatch? If you put your mouse over it, it says you have 2 hours to complete that. Do not go near that test until you are ready to do that test. It's not like I'll click it, do 10 minutes and come out and I've still got 1 hour 50 to go. The minute that clock starts, it keeps going. Whether you go and have a coffee, you come back out, you go back in, it ain't going to change. That clock is going to run down to 0. So I can't say this often enough. Do not go near that until you are ready. So make sure that you've done all your homework and practice and whatever else you want. And then you go in there and you will then start doing it. Now, I'm not going to click on that, obviously, because that would show you what the questions look like and you'd get kind of unfair advantage. But can you trust me that when you click on it, there's a test in there when you eventually do so? Anything else? Yes, I'm now going to try one more time and probably fail to do Pinapto. I will be off to Vegas in about 3 hours from now. I'll be leaving. And so I won't have time to do my usual edit the video and all that good stuff, right? And that's the only time I promise that I'll be missing. And the rest of the time I'll be here all the time. So Pinapto recordings. Yeah, okay. I don't know why the video's not there. I was hoping our video would be there. Since it's not there, let me tell you the best workaround. Oops, the best workaround I have for this. If I go back in here and let's do student mode again. If you go down to the second module, class resources, and you click on chapter 2, this one here, and you go to limits and functions, right, which is what we're doing right now. Let's suppose you want some extra help. You want to you know, some of the stuff we've done today, you didn't take good notes on. If you click on this, there's a couple of videos, and evidently one of my videos never made it. So if I click on this one, there she goes, right? So essentially, can you see that one she's doing right now? Isn't that one an example of factor and cancel, for instance, right? So that's a resource. And now I want to stop you. Shushed. There you go. If you go down a little bit further and you click on here, you'll find my notes, and it basically goes through a lot of the things that we've done in, there we go. It says finding limits using limit laws. Okay, so let me click on this one and then just make it a little bit bigger. Yeah. Can you see what I've done here is some examples of the conjugate method, the factor and cancel method, and so on. Right. So I don't think I'm leaving you high and dry. Would you agree? There's videos you can watch if you want to go back and say, how did that conjugate method work again? There's some printed examples there for you as well. So hopefully there won't be, that's what I'm looking for a phrase, that haven't neglected you, right? That I've given you in place things you can use.